We've already done this. We're just going to expand our knowledge of systems of equations. So from our tow problem, we had multiple representations of tow trucks, and we figured out which one was the best deal, and we found out where they were the same price, stuff like that. So this is called systems of equations. A system of equations is two or more equations with the same variables. So thinking to our tow truck 3-act, we had a fixed price, or we had a total price and a mileage. All of them had that, total price and mileage in the equations, X and Y. And really what we're going to do with systems is we're going to try to find out where the two lines intersect, where they cross each other. So in context of our tow truck problem, where they were the same price actually. And algebraically what this means is that point where they cross is the only point that makes both equations true. So where two lines cross is the only point on two lines where that xy coordinate would make both equations true. Okay? There's going to be three outcomes to these. So do you remember back to like solving an equation? Sometimes there was no solution or all real numbers was a solution. Same kind of idea. We have lines that cross each other just straight up. Doesn't matter the degree. And they cross at this one spot, right?
Is that perpendicular?
It doesn't matter. But they're going to cross in one spot, and that one solution would be an xy coordinate, saying like, this is the spot the two lines cross. And that xy coordinate would be true on the equation for both of those lines. Okay. We could also have parallel lines. And how many times do parallel lines cross each other?
Zero.
Yeah, never. So, no solution. We'll probably, like if we have it on Go Formative, we would just write no solution. So they never cross, so we can't, the answer to that system is they don't cross, there'd just be no solution. They don't cross anywhere. And then if we had the same line, like this line and like this line, they're the same line, where are they going to cross? Everywhere. So a word that you'll see a lot in math for that is coincide. It means the same exact line. They'll cross at all the points. All right? You might also sometimes see like an infinite symbol there.
So intersecting lines would include perpendicular.
Yeah, it doesn't matter to the degree at which they intersect, right? If they cross each other, they're only going to cross each other once.
How do you draw an 8?
Okay. So here's what we're going to do. There's a bunch of notes on this for solving by graphing, and I'm going to simplify it, okay? We're going to graph them and see where they cross.
We have to write that down?
Yeah. We're going to graph them and see where they cross. We'll get to draw today. I like in math when I get to draw stuff. Now you guys are lucky because y'all got like little graphs to write on. When I was in school, man, they made us like make these little graphs and line paper and like eye it. Woo.
Oh man, that's so.
That'd be great.
Back in my day,
Class.
in old 1998 or so, there,
That'd be
you know.
great.
Okay, so we have two lines here. Again, the goal is where do these cross? So the first line, these are in slope-intercept form, which is kind of nice. I can graph the y-intercept. 1, 2, 3, 4, 5, 6, 7, 8. Oh, negative 8. 1, 2, 3, 4, 6, 7, 8. There it is. So my y-intercept is negative 8. My slope is 1. And sometimes on these, I like to like put multiple dots for reference, just because if our line's off a little bit, it actually will like be hard to tell where lines cross sometimes. So here's my line. Dude, I'm freehanding this.
Okay, we ask that every time.
I'm freehanding this baby. Okay, the next one. I have a y-intercept of 1 and a slope of negative 2. And again, sometimes I like to do multiple lines on these because sometimes it's hard to see where they cross. So they're crossing right here. Okay? And that point where they cross, I'm going to write it as an ordered pair. It looks like 3, negative 1, 2, 3, 4, 5. 3, negative 5. And so you might be like, well, Mr. Mack, I drew a line a little wonky. How am I supposed to check it? Well, good news is this 3, -5 is an xy coordinate. And which of these equations should it work in? Both. Okay?
Wait,
So,
I got it to like cross that forward.
well, again, it's... So let's check mine. If I put 3 in for x, what's 3 minus 8? Okay. Money. Put 3 in for x here, I get -6 plus 1. My ordered pair works in both. If you draw your line a little wonky, right, it's not quite on something, and then you go check your ordered pair in the equations, it's going to work in one or neither probably then. All right, let's take a look at number 2 together. So for number 1, I've got a y-intercept, or not, the first equation, y-intercept of 9, a slope of 1/2. And again, I like a personal preference. I like to do multiple points with these sometimes. I just find that it helps me get my line nice and straight. All right, there's my first line. I'll do a little key here. What goes well with maroon? I got it. Pink. Okay. Y-intercept is 6. 1, 2, 3, 4, 5, 6. I got a slope of -1. Make my line through here. And they do cross each other.
Wait, hold on. Let me see.
So,
Oh, I got the same thing.
that point where they cross then, right here, is -2, 8. What did one of these lines say to the other line? You'll never double cross me. I just made that up right now. All right. Still got it, guys. Anyway, let's check out our answer. I'm going to slap a -2 in for x. It better pump out at 8. I slap -2 in up here. I get a -1 plus 9 is... Okay. -2 in here. -2 plus 6 is... Oh, opposite of -2, which is 2. 2 plus 6 is 8. It works. Cool. Now, you might be like, well, Mr. Matt, that's fine and dandy. But what about something like... I don't know. Let's look at something like number 7 on the next page, okay? So what are you noticing about my equations for number 7 on the next page? They're not in slope-intercept form, but that's, who cares? No big deal, man. So what's my personal favorite thing to do if it's in standard form, if I can? You guys, I love intercepts, man. But that first equation, our intercept's going to work nice? No, because my zeta value is not divisible by my a value. So, for that first equation, what I'm going to do is I'm going to solve for a y, which means I'm going to get it into slope-intercept form. We did this a bunch, right? Not new. You're old news, man. Sorry, equation, you're old news. So, I've got a y-intercept of 7, 1, 2, 3, 4, 5, 6, 7. And a slope of 3/5. And again, I like to do multiple points for my slope like that. It just helps me make my line nice and straight, especially since I'm freehanding it on here right now as we talk. Okay? But for this line, let's go Chicago Bulls on this one. On this line, it's not actually very hard to get the slope-intercept form because you can just subtract 2x from both sides. But it's also really easy to get the intercept, so I'm just going to do it. My x-intercept's -3, 0. And my y-intercept 0, -6, right? When x is 0 and y is 0. So -3, that's not the right way. -3, 0. 0, -6. But you could totally do this in slope-intercept form if you wanted. There's my line. And then the question is, where do they cross? Well, they cross at -5, 4. And you're like, well, I'm unsure. The good news is, we can check it. I put a -5 in for x, I get -15. A -15 and a -20. If I put 4 in for y, is -35. Okay? Works on the first line. Put a -5 in for x, I get -10 here. -10 plus 4 is -6. Works on both lines. That point is on both lines. It has to be where they cross. Yeah, maybe. Or I just use a straight edge when I made the key for it.
Oh, and like, do we have to leave it
Yeah, I have to walk you down 2 minutes before lunch. So,
Yeah, it's only-
big idea. To solve a system of linear equations, we can graph them and see where they cross, right? That's the big idea. Here's the lines, where do they cross? That's all you're doing. Always you can check your answers if you're unsure.